of week 10 to start. Week 10, we want to talk about water heaters. Why? Because they add to your heating load and they cost you money. Heating water costs a lot of money because water has a lot of heat capacity. It is a necessity. You have to have hot water in your house, especially in New England because the weather is very cold. And we will discuss what types of water heaters do we have and what are our options and what are the maintenance required for water heaters and will it interact with our heating system or not. In many houses you might have a boiler that heats the house and also heat the hot water. That's not always a good option because in the summertime you'll end up having your water heater, your boiler running throughout the summer and that will cost you money. So during the summertime you're also going to pay for gas or oil. I spend in my apartment like it's around $20 every month even in the summertime just for hot water. So you're paying just for the shower and washing your hands and keeping the water hot in the tank. We'll discuss what is the advantages and disadvantages of all these options. So we want to talk about water heating energy use, how much BTUs are required to heat water, and how does that affect our bill. And we'll talk about energy that has been lost just by storing water for a long time. Because eventually, guys, even if you have a thermos, like the best thermoses they have now, what brand, Stanley or Ready, they have how many hours? A day, 48 hours. Granted that you don't open and close the thermos so many times. Eventually, the heat will leave and whatever liquid is in the thermos will eventually become room temperature to equalize. So, water heating capacity. Water takes time to heat. If you have a water heater just for tea or hot drinks or soup, probably have noticed you can turn it on and it takes at least 3 minutes to heat 1 liter of water. So that's a lot of time. And that's for a heater that's 1.5 kilowatts. So it still takes a lot of time to heat water. So water has a lot of heat capacity. If you have a cup of coffee or hot boiling water, it will take at least 10-15 minutes for it to lose the heat. It's not as solid material or as different liquids. Like for example, black oil has different heat capacity, lower heating capacity, so it absorbs heat and rejects it very quickly. So that's why also black oil is very important for using the car engine because the distance is very small and we want something to absorb the heat quickly and look a little bit fast as well. Water heating efficiency. Again, what is efficiency? We talk about that a lot. Efficiency is output over input. What did I get out of what did I put into the system? So what are you putting when it comes to water heating? Putting energy in terms of heat, air combustion, or electrical coils. And what you're getting out of it is what how much hot water you want to have in your bathroom or for the shower. So there's a lot of differences. And also you notice in the winter time, you have to set your heater at higher temperature because the water traveling from the basement all the way to the second floor will lose a lot of heat in the way because the pipes mostly they're not insulated. A lot of pipes are uninsulated, and that will cause you to lose a lot of energy on the way out. Designs of water heater. What designs do we have? What is the component? What are the components? And what are the options and why there are options and how do they work in our advantage? Storage of hot water. Do we need to store water or not? That's a big question. It depends. It completely depends. You can. And do you need it? That's another question depending on how much you use it and how many people you have in the house and how much flow do you need. So hot water storage is another issue that we have where we are storing water that we might not use for the entire day. And over that time you're losing heat and you keep heating the water and reheating the water. So that's something you have to think about. And currently, they have a lot of on-demand water heaters, which they work well, depending again how much water flow you need. Usually, if you live in a multi-family home, it's better to have a water heater tank because probably the on-demand is not going to keep up. And a lot of people prefer having hot water heater storage, just in case you have a lot of consumption of hot water and on-demand is not working, or it might malfunction. At least you have some water stored in the tank. And the hot water stored in the tank will stay hot for at least couple of days. And probably you go to the basement and you touch your water heater and it's room temperature, which means that it's not using a lot of heat. But eventually you will leak heat from the support, from the pipe connecting to it. Eventually you will leak some heat, and this water that will take a couple of days to become room temperature. What types of water heaters do we have? We'll talk about each one of them. Alternative to water heaters. There are some alternatives. Solar water heaters. There's one I have outside the class here. That's a solar water heater you can put in your yard or on your roof, and it will heat your water during the summertime, so you do not need to increase the water temperature. So what is the water temperature coming out of your faucet? Huh? So from the hot water it should be 110, 120.
Oh, okay.
And when you store it, it should be above 140. If you store water between 90 and 110, you are promoting the growth of some certain kind of bacteria that is very, very bad for you to get into your body. So we have to pay attention to that. Bacteria loves heat. And there are some bacteria that thrive even in very high temperature, and some of them can even stand boiling. There are some viruses and bacteria that require around 400 degrees to die. Yeah. So boiling everything does not always sterilize it. So keep that in mind. Probably if you know anybody who works in a hospital, they'll tell you there are some stuff that you cannot kill by heat or temperature. Water heater, they consist of a heat source. You're always going to have a heat source. What sources do we have? Either fuel or combustion. You're gonna have a combustion. Either you're gonna burn some gas, you're gonna burn some oil. You can have a water heater that's electrical, so you're gonna have a heating element, or you're gonna have a heat pump. You can have solar. These are the options we have so far. You need a heat exchanger that will exchange the heat and temperature between the hot water and the cold water. And sometimes you might decide you want to mix the water coming in from the boiler with the hot water coming to your bathroom, and sometimes you might not, depending on the water quality and what kind of water you should put into your water system. Piping system, what kind of piping do we have? Again, I will show you next class in the lab how do they interact. How do you have a boiler that has a coil just for heating the water, goes through it, and a lot of places they have a separate water tank, and we'll go and look at the individual. Plumbing fixtures, showers, and faucets. So this is another way to. This is where you're going to spend your water, and it's very important to economize the showers and faucets. And I think they came a long way from before. However, some of them have different flows than the others, and it's also a personal preference. Do we go with tack or tackless? So by tack we mean storage as a backup, and sometimes we go with tackless, which is also known as on demand. You turn it on and heat the water right away when you need it. Again, on demand became very, very popular because they came in different sizes now. Let's say you have a guest bathroom or half a bathroom. You don't want to pipe all the way from the basement to the bathroom, and probably doesn't even have a shower. Only the pipe you have is a pipe coming from the basement all the way to that sink, just to wash your hand. You can buy a small water heater that's around like 1 gallon per minute, which is enough for that sink, and it will turn on whenever you turn on the water. That will be very economical for that utilization. And if you don't use the water, you can turn it off. Turn it on when you need to, and it will heat instantaneously electrically. So we have those same water heater in the lounge with it heats the water once you hit the pedal, hold on, to heat on demand at the moment. So when we think about heating on demand, what do you think? What kind of heat exchanger do we need? So think of the water flow. If you have one, if you we'll go back to the old equation. So this is the heat transferring from the water, from the hot water to the cold water. We'll go again with the area times U times delta T. And let's say the water we want is 180 or 140 degrees, and the water coming from the city is around 50, and sometimes 45 degrees. So that's a lot of heat. That's around 90, so 90 degrees. This is the material of the copper. So copper. And what we need is a lot of surface area to make that happen for on-demand water heater. So you want the water to come in. Let's say this is my on-demand water heater.
What is this for?
This is for the heat exchanger. If you have a heat exchanger, this is what it. If you look at the heat exchanger in your boiler, you see it's a pipe going back and forth. It's a regular pipe. If you look at that, look at the back, that AC, the evaporator. That's a heat exchanger. You see how it has fins and pipes going back and forth. A heat exchanger is a radiator that connect two fluids together. So if you look at the heat exchanger coming into an on-demand, the distance, it goes back and forth. It comes in at 40, and it comes out at 110 or 140. So the distance is very small. To make this smaller is very challenging. What you need to do is to have a lot of surface area going through the pipe. So if you look at the pipe, and I'll show you one on the cutout in the lab. It's a copper pipe, of course. Copper is the best conductor. And it has a lot of fins around it. A lot of spirally fins around it, so the water will go through it very, very slow, and it can give you that flow. And by the time it will start getting temperature, and by the time it comes out, it has to get enough temperature to be enough to use. So heat exchange is a big design. It's very important. And many things because there's a battle going between having big surface area and then losing flow. So we can have a big surface area and having a lot of fins from the inside here, but imagine if we have the fins from the inside. The water will be hard to pass, especially if you want to go faster. So there's a lot of kind of advancement when it came to the coil heat exchanger that makes the air goes faster and still grasp and get some heat. We talked about geothermal last week. We said the smaller the heat exchanger and the more efficient heat exchanger, the better we can absorb heat from small location. Otherwise, we have to have a big tank and a big storage. So water heating and energy. One talk about energy. On average, there's 3,500 kilowatts hour of electricity if you're using water using electrical heaters, or 230 therms of gas per year. That is a lot of therms. The therm is 100,000 BTU. You agree? Okay. Take that as a yes. That measures to 15% of your electricity bill and 25% of your gas bill. That's a lot. If you're paying $100 a month for electricity, 15% of that is for water heater. And we talked about appliances. If your appliance uses hot water, probably you should consider buying an appliance that has its own water heater. And again, with the laundry, we said there's a hot cycle, a warm cycle. You don't always need to use the warm cycle. The cold cycle will do, and that will actually take a lot of your hot water supply.
So do most dishwashers and wash machines have on-demand small water heaters
The new ones,
built in?
the new ones. The old ones are within like 10 years, probably they still have a hot water supply. So you can look, if you see two pipes coming into your dishwasher, one of how it's called probably is using your hot water tank. So every time you turn on, it's going to use the water that's in your tank. And probably you will need to have your own tank. So tank, if you have a laundry, a machine, a washer that requires hot water supply, or a dishwasher that requires hot water supply. And again, you can replace those appliances with something more efficient. So we have a lot of losses. The demand, that's you. If you think about it, a person consumes on average around 20 gallons of hot water a day between washing your hands, between washing dishes, doing laundry, and showering. So that's the demand. And the standby, we said if we have a tank and have standby time, that's lost heat to the ambient and atmosphere. Then distribution. Distribution is very huge when it comes to water, because again, the water in the pipe is 140, going through a room that is 50 or 60, there's a lot of temperature difference. So it goes through distribution, and the distance is really long. So usually you have your boiler in the basement, coming up to the second floor bathroom, that's a long distance to come. So you're losing a lot of water, a lot of water temperature on the way. So this estimate is kind of old, but still valid. And how much do we use per day of hot water? And as you can see, communal use or the consumption per person. For one person is around 25 gallons, because again, you're gonna do your own load and do your own dishes. It's gonna be more. When you have communal living, probably gonna use combined loads or combined dishes, which will use less hot water. Most of the hot water consumption is gonna be for the dishwasher again and clothes washing. Talking about efficiency again, this is my input. I put in like few gallons of water, oil, a lot of tons of gas. What's happening? If you do combustion, there's always 10 to 30% combustion efficiency loss. What is that? That's the theoretical amount of BTUs in the gas and how much you got out of it. So in theory, diesel oil has 140 BTUs, but you cannot burn all of it. You're not going to get 140. So the maximum you can get out of that is on 90%. So this is 10% lost. So it's going to be around 125,000 BTU actually in the boiler. The 125,000 BTU is in the heat exchanger. How much you get out of it into the system, that's called thermal efficiency. And when you go look at condensing boilers, they'll say this condensing boiler is 98% efficient. What does that mean? That means it's like whatever heat you burn, you get 98% out of it. So this is combustion efficiency, depending on how efficient your boiler is. But some of this you cannot, there's no way around it. At least 10% is the minimum you can have as losses. Then, standby losses, 0 to 70. What is that? What is that? That's the time you're not using the hot water tank, and it's just leaking into the room slowly. Distribution losses, that's again the pumping power losses from the basement all the way to the second floor, first floor, and the pipe that are not insulated. So eventually you'll get an output of 35 to 70% of your input, which is okay, but it's still a lot of losses. What can you do about it? There's a lot of things you can do about it, but again, hot water is a necessity. You don't want to be uncomfortable. For example, a lot of people stop doing baths. That's a lot of consumption. Every time you draw a bath, that's around 8 gallons of hot water.
Saving your dirt.
Huh?
You're saving your dirt.
Yeah, I know. Is it a graver?
Yeah.
Yeah, I'm sitting my own film. But you gotta think of bath was something from the past because they didn't have water flow plumbing. So you just sit there and it will equalize. It's 100% dirty, you'll be like 60%. So a lot of you actually do a bath and do a shower, so you're wasting water. So think of a lot of water. And in the Northeast here, we have a lot of, not the luxury of having a lot of water. If you go to Arizona or Texas or California, that's, yeah, there's a limit to how much you can consume of water, which makes sense.
Say in California, aren't they going to start a law for something that you can only use so much a day or something like 50 gallons?
There's a lot of places that have that. Even some towns in Massachusetts they have that. You know that in some, especially with drinking water,
South Africa a couple of years ago, they were only allowed 3 minutes of water.
Yeah, like Brickton, Mass, they have laws, huh? Yeah, I think they have low supply of water. There are some reservoir, but they're getting less and less, no matter how much you think, but there are some less water, fresh water coming in. And you have to consider something else, like wastewater treatment costs money. So even though water is plentiful, the wastewater treatment is costing money and also affecting the environment. Something also wrong with I mean, it used to be wrong, I'm trying to correct that now, is the salt that they put in the snow. So whatever salt you have in the snow, you cannot let that wash away. There's limit to how much you can put in that and how much you can dump snow with salt into the lakes. Because you're trying to predict the water supply. Over time that accumulates. I remember in 2013 when we had the highest snow in history, and they didn't know where to put it. There was no place to put it, and 3-lane street became 2-lane street, and they were trying to find a way to dump that in lakes, but they could not. The EPA would not allow them because the amount of salt in it is high.
Put it in,
Yeah.
in grocery stores, parking lot.
Yeah. It was very, very intense. Okay. Let's talk about the sticker and how much you are willing to invest in a new boiler. Something called the energy factor. Guys, let me finish this. I'll let you go.
Oh.
So, water efficiency, and when you're going to read in the label when you buy a new boiler, energy factor, the ratio used for water heating output to the total energy consumed is between 0.5 and 2 energy factor. So that's something you'll see in on the label. First, our rating was an old rating that's not there anymore, and probably you'll see it in big boilers, which means the amount of gallons you can draw out of that tank in 1 hour if you have a continuous flow. And finally, gallon per minute, that's the most common one you'll see for a lot of on-demand and new boilers, and new tanks now. 1 gallon per minute at certain temperature. They'll tell you this on-demand will supply you with 3 gallons per minute continuously. So it will be able to heat based on the incoming water temperature and the output temperature saved is what you're getting for gallon per minute. Okay, I'll stop now and let you go until 5 minutes. See what's this.